As I said before, Android also allows applications to write to external memory. One extra twist that you'll need to consider, however, when you do this, is that external memory can be removable. For example, when it's provided by an SD card. And because of this, that media can appear or disappear without warning. And therefore, when your application is going to write to external memory, you'll first need to determine the state of the external memory. Now, one way to do that is by using the environment class's getExternalStorageState method. That method will return a value indicating the current state of the device's external memory. And some of those values are shown here. For example, there's media_mounted, which means that the media is present and that it's mounted with read and write access. There's media_mounted_read_only, which means that the media is present and mounted but has read-only access. And there's media_removed, which indicates that the external memory is not present. And of course, there's several other values as well. If your application wishes to write to external memory, then it will need to request the appropriate permission. Specifically, you'll need to add the write_external_storage permission in the application's Android manifest.xml file. Our next example application is called Data Management File External Memory. This application reads an image file from the res/raw directory. It copies that file to external storage. It reads the image data back from that external file, and then it displays the image on the screen. Let's take a look at that application right now. When I start the Data Management File External Memory application, you'll see an image displayed on the screen. Here goes. Let's look at the source code to better understand where this image data came from. So here's the application open in the IDE. Now I'll open the main activity. In the onCreate method, the code checks the external storage state to ensure that the media is mounted and that it's readable and writable. After that, the code gets the external file directory where pictures are normally stored. And it constructs a new file object pointing within that directory. Next, it checks whether a file actually exists on the external memory. The code then calls the copy image data to memory method. Let's look at that method. Now this method starts by creating a new output stream that will be used to write to a file on the external memory. Next, it creates an input stream so that it can read image data from the res/raw directory. And finally, it copies the data from the input stream to the output stream. When this method completes, there will be a new file in external memory. Now, going back to the onCreate method, the code gets a reference to an image view and then sets the image URI to be the file that was just created in external memory. If your application creates temporary files, then you may consider writing these to cache directories. Cache files are temporary files that may be deleted by the system when storage is low, and these files are removed when the application is uninstalled. And you can get access to the cache directory by using the context class's getCacheDir method. This method returns the absolute path to an application-specific directory that can be used for temporary files. Alternatively, you can also use the context class's getExternalCacheDir method, which returns a file object representing a directory for cache files in external storage. When your application reads and uses larger amounts of structured and complex data, you may want to put that data in a database. Android provides an implementation of SQLite, which allows applications to create and use in-memory relational databases. SQLite is designed to operate within a very small footprint, say less than 300 kilobytes of storage. SQLite is, however, a full-fledged relational database. It implements most of the SQL 92 standard, and it supports highly reliable ACID transactions, which means that the transactions are atomic, consistent, isolated, and durable. To use an SQL database in your applications, Android recommends that you use a helper class called SQLite Open Helper. And what you'll do is you'll create a subclass of this SQLite Open Helper class. And in the constructor for that class, you'll need to call the superclasses constructor, passing in some information about the database you want to create. Next, you'll override the onCreate method, the onUpgrade method as well. Now typically, in onCreate, you'll execute one or more create table commands which define the database's structure and layout. And after that, you'll use the SQLite Open Helper methods, for example, to open and return the underlying SQLite database. And then you'll execute operations on the underlying database. Our last example application is called Data Management SQL. This application creates an SQLite database and then inserts several records, some with errors, into the database. The application will also display a button labeled Fix. And when the user presses the Fix button, the application will delete and update some of those records that were just inserted. And it will then redisplay the updated database records on the screen. Let's take a look at that application now. Now, I'll start up the Data Management SQL application. As you can see, the application now displays 4 database records, each containing a record ID and the name of an artist. At the bottom of the screen, there's also the Fix button that I mentioned earlier. When I press this button, record number 2, Lady Gaga, will be deleted. And record number 3, Johnny Cash, will be updated to correctly spell the artist's first name. Let me hit the Fix button now. And as you can see, record number 2 has been deleted, and record number 3 now shows the correct spelling of Johnny Cash's first name. Let's look at the source code for this application. Here's the application open in the IDE. I'll now open up the main activity. Here in the onCreate method, we begin by creating a new Database Open Helper instance. Now that class is a subclass of SQLite Open Helper. Let's take a look at that class. The constructor for this class calls the superclasses constructor, passing in information such as the name of the database and a version number. Now this class's onCreate method receives an SQLite database object and then calls its execSQL method, passing in a string which corresponds to an actual SQL command that will create a table named artists. And that table will contain 2 fields, an integer ID and a string for the artist name. This class also has a delete database method, which simply deletes the database. Now going back to the main activity, the onCreate method continues by getting a reference to the underlying database that can be used for reading and writing. Next, it calls the clearAll method, which just deletes every record in the database. After that, the code calls the insertArtists method, which inserts a number of records into the database. Now, this method first creates a content values object and then puts information into that object corresponding, in this case, to the artist's name, Frank Sinatra. Next, it inserts the record into the artist table by calling the insert method. Now, since the ID field is auto-generated by the database, the application doesn't need to include it here. Next, the code clears out the values object and then adds a second record for Lady Gaga, a third record for Johnny Cash, and a fourth record for Ludwig van Beethoven. Now, going back up to the onCreate method, the code calls the readArtists method, which reads all the records in the database and returns a cursor object. A cursor is essentially an iterator over a set of records returned by a query operation. And this cursor is then used to create an adapter for the list view that will display these records on the display. And finally, the code sets a listener on the Fix button. When the user presses this button, the code calls the Fix method. Let's scroll down to that method. This method first calls the delete method, which finds the record with the artist name Lady Gaga and then deletes it. And after that, the method creates a content values object with the right spelling of the name Johnny. It then performs an update operation that first finds the record with the misspelled name and then replaces it with the correct spelling. If you need to debug your database applications, there are several things you might need to know. First, the database files are stored in the data/data/package-name/databases directory. And you can examine these files by first opening a shell to the emulator or to your device with ADB. For instance, if your emulator's name is emulator-5554, then you can issue this command to open a shell. And once the shell is open, you can then use the SQLite 3 command to open a connection to the database itself. And from there, you can type, for example, .help to get more information about the specific commands this program understands.